Hello everyone, welcome back to my channel. I hope you guys are doing well. This is the fifth video of the series Ease into Coding along with Complexities. You must have not checked my previous videos from this series. I'll be providing the links in the I icon above. You can access them from there. Also, if you haven't subscribed to my channel yet, do subscribe to my channel and also hit the bell icon to never miss an update. In this video, I've taken again a problem from LeetCode. If you must have gone through this problem, you'll be knowing that in this problem, we'll be provided with an input array or input vector, and we'll also be provided with one more variable named target, which is the sum to be obtained by adding any two of the elements from the input vector. And it is also said that we can clearly assume that there is only exactly one solution, that is, there exists only one pair of elements which will add up to that target. And the thing that we need to return over here is a vector that consists of the indices at which those elements which add on to the sum in the target belong to. And we would be solving this problem, but before that, let us look what are the approaches that we can go to. First approach would definitely be the brute force approach, but as many of you must have already guessed, which will not result in an optimal solution. So what can be the other approach? The second approach that we would be using would be the map approach, the hash map approach, about which I'll be coming in a while. So let us quickly head to the whiteboard and let us start solving this problem. For that, this is the first approach I had said, and let's look basically what we'll be doing on this. So this is the brute force approach, and as the name suggests, the first thing we would be doing is a loop variable would be starting from 0 going up till the last but one element, and the second loop variable will just be starting from the element next to the first element and will again go till the last element. So as it must be clear that the complexity this approach or the solution would be something like here n minus 1 and here also n, so which would add on to nothing but O of n square, which is obviously not optimal. But still, as this is the first approach that comes into everyone's mind, let us quickly go through this approach in order to understand what would be the solution regarding to this. So we would be starting from 0 going up till the last element. The second element will start from the element just after that, and it will go up till the last element by doing a j++. Then after in each iteration, we are just going to check whether our nums of I plus nums of j equate up to the target, that in this case that is given in our question is 9. As you can see here, the target is given as 9. So we need to be comparing two elements in order to find that. So as you must have figured out that our I would be basically pointing at index 0 as it's starting from there, and our j will be pointing at index 1. So as you can see in this case, it's pretty much clear that the answer would be resulted just by adding the first two elements, that is 0 plus 2, which would result in 9, and which would be equated to the target variable, that is 9, and we would get a true value, because of which we would v1 dot pushback I, which in this case is 0, and v1 dot pushback j, which in this case is 1. As simple as it is. This question is the first question in LeetCode, and as the ranking, you can see it's very easy and very up to the point if you go by brute force approach. And obviously, if you don't find it at index 0 and 1, your I will move head on till the second index, and consequently your j will be iterating to 1, 2 until the last element, and finally you will definitely find a pair and you will be returning those indices, because as mentioned in the question there, we can clearly assume that a solution definitely exists for this problem. Now let us quickly go back and submit this code in order to check what our runtime would be, in order to see that whether this was an optimal approach. And as you can see, it's definitely not the optimal approach, because it's taking more than 1000 milliseconds to run this code, which is just faster than 5.05% of the online C++ submissions. So in order to make this code efficient, what we would be doing is definitely going for a better approach than this. So this concept would be new for the ones who have recently started with uh, coding and the new concepts in order to optimize their coding. So the container that we will be using over here is the unordered map, or in short, we will be using the hash map in order to implement our code in a most optimized manner. So here, as you can see, let us before explaining the code, let me tell you what we'll be doing in this approach. In this approach, first we will be making an unordered map, because we are not sure about the ordering, and we actually don't even require the ordering of the elements in our map. So we will be using an unordered map. Then what we'll be doing is we would be first checking whether our the target minus num of I element is present in the map, which means in this case we'll be checking for, if we start from int I equals to 0, in this case we'll be checking for whether our this one, that is target, in this case as given by the input is 9 minus this element that is 2, that is equals to 7. We are checking whether the 7 is present in the map. But as you can see below, just for your understanding, I have created a map which will finally look like, but it's right now not created. Right now the map is empty because we have not added any elements. This is something which is going to be the final map, so don't get confused right now. We'll be right now checking whether 7 is present, but since our map is empty right now, 7 won't be present, and this if condition won't work. And if it is present, what we would be doing is we would be noting down the indices of 0, that is indices of the nums of I, and indices of the target minus nums of I, which is exactly the two indices that are required, and we would be adding those to our vector, the final vector, that is v1, which is to be returned as the first and the second element, and finally we will return at that instance. That is, we are not going to check anywhere further, because we know there is exactly one solution for this problem. Now, for those who didn't understand just by explanation, I'll be explaining it by iterating through my code. So pay close attention in order to understand what this will result into. So this is the basic vector, which is to be the final vector in which we'll be storing the two indices that are obtained. Then we are going to declare an unordered map named m1, which has int as a first element and int as a second element. That means a map is nothing but, for the ones who don't know what a map is, map has two values. That is, the first one refers to the key and the second one refers to the data in that key. Basically, an array is also a type of map in which the first key, that is default, which starts from 0 and goes up till the number of elements -1 in that array. But in map, you have the leverage to decide what your key will be. In this case, we have taken our key to be int itself, because we know that the elements over here are int. So there is no problem. But sometimes you have strings, you have chars. So at those moments, this map is going to be a big help. So coming back to where we were, we declared this unordered map. After that, we are going to iterate towards the entire set of elements, that is elements. And what we are going to check, first we are going to check the reason that first we are not adding the element, that is what m1 nums I is equal to I will do is basically that will result into m1. If the nums of I in the first case would be 2, then it will make m1 2 equals to what is I is 0. So this is the element that will obtain. This is the first element that would be added to the map, and the rest are still not added. So don't get confused, only 2 and 0 will be added. But the reason we are not adding first and we are checking first is because if in case we added 2 and our target was 4, then 4 minus 2, that is 2, would already be present in the map, which would result into this function being true, and we would end up returning 0 and 0. But as they have told in the question that our in the description, if you must have noted, that our indices need to be that cannot be the same index, and it needs to be different. So for that we need to make sure that we add this element just after checking first whether the target minus nums of I is present in the map or not. After that, what we do is as in this case it is the first element, so it's pretty much sure that that element will not be present. So we clearly add that, and as you can see it is there in the map. After that I gets incremented. Once this is done and it's added in the map, I gets incremented and moves to the next value. That means I is right now pointing at 7 or index 1 and at element 7. Then what we do is again we do this m1 dot find, and for the ones who find it difficult that what this exactly if condition is doing, let me even explain that to you. I hope that many people, I guess that many people right now don't know what a map and its function is. So I just explained you map few moments before. Now let me explain you what this dot find function does. Usually dot find function returns a iterator to the element that you search for. That means here we are searching for target minus nums of I. That means we are searching for if when we were at 2 we were searching for 9 minus 2, and so that if we get 7 in the map, then we can directly send these two indices in the vector and return the vector. And that's how this works. And since we are getting an iterator back, and make sure that dot find m1 dot find or map dot find always checks for the key, not for the value. That means just in case if you just consider that your map looks has some keys like 2, 4 and 3, and just think you're checking for 5, what it does is the iterator starts iterating. It will first check whether this 2 is equals to 5, no. It will check 4 is equals to 5, no. It will check this 3 is equals to 5, no. Then it will come to the map dot end, which is an iterator pointing to the end of the map. And that's exactly the case we are checking over here, that if our m1 dot find is not equals to m1 dot end, that means if the element is present in the map. Hence if the element is not present, then it's very much sure that clear that I've told over here that it will reach the end of the map, which will result in this function being false. But if in other case if we were searching for element say 4, that would be achieved at this point itself, and that would result into m1 dot find being pointing to here and not at the end m1 dot end, which will result in this being true. And that's the moment we are going to execute this if condition. So coming back to where we were, that I was telling that I is pointing in, to the element 7 or index 1, then we are going to check whether m1 dot find target minus nums of I, that is 9 minus 2 in the nums of I, sorry, not 9 minus 2, I'm sorry, it will be what is nums of I. Nums of I is 7 in this case, so we are checking whether 9 minus 2, that is 9 minus 7, that is 2, is present in the map, and yes, 2 is present in the map. So what are the things we are going to do after entering the if condition? That is, we are going to make v1 of 0. That is, this vector we have declared it a size of 2 because we know that only 2 indices are to be returned. So the first element, that is v1 of 0, will be equals to m1 of target minus nums I. Now what that will return? As you know, in array, if you need to access any value, as you can see, this is the input array. So if you just think I've told you I wanted to access 15, it will definitely tell me that the right syntax for that would be a of 3. But here what we seek to do is in map, in the case of map, as you have self-declared the keys, you need to provide the key. So what target minus nums of I will be? Target is 9, nums of I is 7, so 9 minus 7, that is 2, and 1 of 2 will return 0. That means, in short, what we are going to do over here is we have this array, input array or input vector, we are inverting it, and we are making all these elements as the key of the map, and we are making all the all the indices as the value of this map, which can later be helpful as it is becoming in this case. So what will m1 of 9 minus 7, that is equals to 2, that is m1 of 2 will return? It will return you 0. That means v1 of 0 will have the value 0, and v1 of I will have the current index, because these are only the two elements which add up to the target. So v1 of I will have the value of 1, and at that moment itself we are going to return this v1, which is having the values of 0 and 1, which is the final thing that we are doing. So usually maps, unordered maps, help you in this case, in which you have to self-declare the keys as some values other than the normal arrays, and unordered maps usually help at those instances when the values are not direct, or you're or not continuous, or you're not concerned basically by the ordering of the elements in your container. So this was all with the two approaches, and as you must have already figured out that the complexity of this is only n square, which is definitely less only O of n, order of n, that is, it has a linear complexity, but our previous solution had order of n square, which was definitely not optimal. So let's quickly go back in order to comment the previous code and run this code to check whether what is the submission time and what is the run time that we received for this approach that we just made. So as you can see, it is 16 milliseconds. I even got around 12 milliseconds before this. So yeah, that was all. It is greater than 81.87% of the C++ online submissions, which is that we made our code optimal. So that was all with these two approaches. If you like this video, do hit the like button, and if you have not subscribed yet, make sure you subscribe my channel Decode the Code by clicking on the subscribe button, and also hit the bell icon to never miss an update. If you have any doubts in this video, or you have a better approach than this, let me know in the comment section below. Always open to learning. And also share it with your friends who are stuck with this problem or are looking for a better approach to solve this problem. That was all with this video. I'll be meeting with you in the next video shortly. Till then, bye bye, take care.